Most of us have heard the atom way before a science class in high school, maybe middle school, elementary school, or even at home. But where did the idea of atoms come from and how were we able to prove it? The first person credited with the idea that everything was made of atoms was thousands of years ago. It was a Greek philosopher named Democritus, and he proposed that if we cut everything in half, smaller and smaller and smaller, eventually there was a smallest uncuttable piece. Even the word atom comes from the Greek, from uncuttable. So wood was made of tiny atoms of wood, air was made of tiny atoms of air, and everything was made of the tiniest little atoms of itself. But this didn't explain a lot of how things changed, and there wasn't any proof. But it took a long time before we had the right equipment and the right explanation to get more proof. About 200 years ago, in the 1800s, John Dalton took the data of a lot of different scientists and put it together to prove the idea that everything was made of atoms. One of the biggest pieces of his atomic theory was that atoms of separate things, separate elements, like the ones I'm standing in front of here, can be put together to make compounds. So they combine and they can break apart, but we can't break that atom into anything smaller. So each element was made of a certain type of atom, and all of one element was the same, all of another element was different, and we would put those together. He had data, he had experiments, and he had measurements that supported this. But as technology got better and better, we got to the place where we could measure smaller and smaller things. Almost 100 years later, J.J. Thomson proved that atoms can actually be broken into smaller pieces. By measuring the negative charge that all particles had, he discovered the electron and proved that atoms must be divisible. So every atom isn't the smallest piece. We can break it into other smaller pieces. The picture he came up with the atom looks like this right here, and it's called the plum pudding model, where we have our positive atom with little dots of negative electrons spread throughout. As more and more experiments were done, they wanted to find more about electrons. And one of the things that they found out was that those electrons weren't just randomly spread out. The parts of the atoms had certain locations. Most of the atom, most of its mass, and most of its particles were actually in the middle. That part is called the nucleus, and it was discovered by Ernest Rutherford in about 1911. He did an experiment with gold foil, which is a lot like the aluminum foil that we wrap our leftovers up in, and was able to prove that all of the positive charge and almost all of the mass was in the center of the atom, and the electrons actually took up a lot of the space outside of there and moved around, and they weren't staying in one place. To find out more about electrons, Niels Bohr did experiments with how atoms absorbed and released energy and was able to prove that electrons don't go just wherever they want to go. They have to be in certain places or in certain energy levels. This is what allowed us to then figure out how atoms act, how they bond, and how they react by understanding where electrons are in the different energy levels. After the Bohr model, there's been a lot more in depth investigation to find out that electrons don't really orbit the way that planets do around the sun, but they are outside the nucleus. We have our protons and our neutrons outside the nucleus, and inside the nucleus. The electrons are outside the nucleus, and they do have energy, but it's hard to know exactly where they are and exactly how they're moving. The field that explains this weirdness is called quantum mechanics, and it allowed us to open up a lot more research and to invent a lot of new technology. So, our current model of the atom was built from that understanding of there must be a smallest piece all the way up to what those small pieces must be doing. The proton, the neutron, and the electron are the particles we focus on in chemistry, even though we found that they're made of smaller particles. When we think of the protons and the neutrons in the nucleus and the electrons in the energy levels, according to Bohr's model, we can explain almost all reactions, all compounds, and all bonding. The exact behavior of those electrons is still something that's being investigated a lot. We can make great observations, but once we are able to know a little bit more about them, we'll get into the next big discovery in chemistry.